Okay, Reagan doesn't want to do electrostatics because she's really bad at it, so, like, we'll talk about it really quickly. So there's positive and negative charges, and like charges repel, and opposite charges attract. So, like, this is a positive, and this is a negative, and this is a negative, and this is a negative.
I say just learn the equations.
That didn't help you, did
try
it?
and Robin Bodge pie your way through. Shout out to my homeboy Robin. We're not friends.
Yeah, so there's that. Insulators versus conductors. I have that written on here, and I don't have anything else written, so we're gonna move on. Yeah. And then, so, there's this little thing that I have drawn out that I don't want to redraw, so, like, if you look at that, you may just want to pause, flip the camera, and read it. It's basically, like, if you touch a conductor, then it, like, gives it stuff over, but if it's grounded, then something else happens, and if it's an insulator, something else happens, and you just have to kind of know. We're waiting for the AP test tomorrow.
Yeah.
Something very important is Coulomb's law with electrostatics. There's a lot of equations like F equals G M1 times M2 over R, and
which are on the equation sheet. That's why
all these other things, and then the small, and then isobars. I said isobaric one time in class, and they're all like, "You're so dumb," and I was like, "It's pretty close," and they're like, "No, you're not." I just wanted to let everybody know that I was pretty close. Isobars are points of constant pressure, and they're scalar lines, so you can't really tell if they're positive or negative. Yeah, and so, yeah. But if the charge is positive, then they go up as you go closer, because closer means higher potential, and farther means less potential. But if they're negative, then it's the opposite of that. I don't really know, but I'm kind of thinking maybe. Yeah. And then, so uniform electric fields is when F is constant, and it has something to do with kinematics, apparently. And then force exerted on the charge by the field is EQ, which is important because there's two types of forces.
It's also on the equation sheet.
Yeah, but you have to know what it means.
Yeah. Our viewers are smart.
E equals force divided by Q, which is force on little q exerted in a field, E. And then E equals KQ over R.
Like EK, you're talking in Spanish.
Okay. E equals KQ over R squared, which is a field created by a big Q. And then F equals K Q1 Q2 over R squared, which is a force of two charges acting on each other, which is just more information that you can find on the sheet. And then, as you go away from a positive charge, energy is higher. I don't actually know. That doesn't seem right, so I'm just not going to say it. V, which is apparently something in this unit as well, equals U over Q.
That's on the equation sheet.
I don't even know how that even is compared to anything. When we're talking about electric fields, higher potential is closer to the positive, and lower potential is closest to the negative.
Oh, the things. Never mind.
Yeah, no, that's right. I think you should say it.
I don't.
The charges, if it's a positive charge, it's always going to flow to the negative field. Electric fields always point to lower potential, so they're always going to point to negative because they're what would happen to a positive charge. And a parallel plate is a
capacitor. That's actually what I was going to say, but then I was like, that can't be right.
Yeah, it is. Oh, and if we're talking about conductive spheres, their positive charges are all along the edges, and so there's nothing really in the middle. But when you measure something, it's from the middle to the outside. And then all charge, yeah, so, as long as we're outside of the sphere, R is greater than little r. Big R is greater than little r. No, if R, you know what, just forget all the R things that I said because I think I said it wrong. E equals 0 if it's inside a conductive material. Yeah, that's true. And V is constant throughout the conductor. Because that's just potential energy, and it's just like constant no matter where you are, because everything's equaling each other out. And then some more Q things, which is messing up. I'm pretty sure I did really bad on this test too, because this is.
I got a
probably-
60.
I think I got a 70. Which isn't as bad as you, but it's still not good. Maybe all my notes are wrong. Maybe we shouldn't be telling these people things. Does this have to do with DC and RC circuits?
No. That's the capacitor unit.
Am I in the capacitor unit?
No. But you started talking about capacitors.
I talked about parallel plates.
Okay.
Which
I think we're
fields.
good.
Bye.
Bye.